What happened, Pranav, to your network? Okay, now we are taking up a concept of distance between parallel lines. Now let's say we have been provided with two lines which are parallel to each other. Okay, and let me assume their equation to be ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0. Now, why did I choose ax, a and b in both the equation is because when two lines are parallel, remember what I told you when I was discussing the angle between two lines? That when two lines are parallel, you can choose to have the same ax plus by term for both the lines. So as to say that two parallel lines will only differ from each other in the constant terms. Okay. The other term can be kept the same. Okay. They can be same or they can be proportional. Are you getting my point? So what I have done, I have made it in such a way that both are same here, over here, just to make my life easy. So how do I find the distance between these two lines? Okay. Now the concept that I would use over here is that the distance between these two lines basically can be found out by choosing any random point P on one of the lines. Okay, let's say I call this as L1 line and I call this as L2 line. If I choose any point P, any point, it doesn't depend upon the point actually, any point, and finding its distance from the other line, that will give you the distance between the parallel lines, isn't it? So even if I take the P over here, okay, and I find out this distance, okay, it will still be D only. It doesn't make any difference. Okay. Now, in order to find P, you can choose, any point that you know on that line, or the best safest way would be to take, one of the coordinates to be 0. Normally, I take x as 0. So if you take x as 0, your y automatically becomes minus c1 by b. Okay. So P point can be taken as 0, minus c1 by b. Okay. So you have got a point on this line L1. Okay. Just find out the distance of P from L2. So this is like your alpha beta and this is your given line. So how will you find out the distance? Mod A alpha would be 0. Beta into B or B beta will be minus C1 plus C2 by under root of A square plus B square. That is the square of the X and the Y coefficients of line L2. Which gives you on further modification mod C1 minus C2. See, it doesn't matter whether you write minus C1 plus C2 mod or C1 minus C2 mod. Okay, by under root of A square plus B square. So please make a note of this. This is your distance between two parallel lines. Please note it down. This is the distance between two parallel lines. Okay. One thing to be noted over here is that in order to find the distance between two parallel lines, or in order to use this formula, okay, very important thing I would like to highlight over here. You should have made the coefficients. So before using this formula, make the coefficients of X and Y the same in both the lines. Same in both the lines. Okay. Now, many times they will try to trick you by giving you proportional coefficients, right? So that time be very careful. Okay. Let me take few examples for it. Let's say, yeah, let's say I start with a simple question. Find the distance between these two lines. Find the distance between these two lines. Now here you are safe because both these parallel lines have the same coefficient of X and Y. Okay. But many a times they will try to deceive you by giving you proportional coefficients. For example, there is a 5x minus 12y. Here they may give you, let's say 10x minus 24y. Okay, kind of thing. So before you start the application of the formula, make sure you have made the coefficient of X and Y same. Same, not proportional, same. Okay. How would you do that? By multiplying with the proportionality constant, right? For example, here it was 10x minus 24y, then multiply the first one with a 2. or you divide the second one by a 2. It's your call. The result is not going to change, don't worry. So here, what is your answer? Tell me. Simple. C1 minus C2 by under root of 5 square minus 12 square. Correct? 5 by 13. Okay, 5 by 13. Easy. No problem with this. Okay, so let's say if I change the question and I give you another one, find the distance between, let's say 3x plus 4y minus 1 equal to 0, and let's say 6x plus 8y plus 3 equal to 0. Okay, how will you do this? How will you solve this question? Okay, so first thing, you have to make the coefficient of x and y same in both the equation. Okay, here they are proportional, not the same, proportional. So what I'm going to do is I'm going to multiply this with a 2. So I'm going to use 6x plus 8y minus 2 equal to 0 and 6x plus 8y plus 3 equal to 0. Okay, so now mod of minus 2 minus 3 by under root of 6 square plus 8 square. So your answer will be half in this case. Is it fine? Pranav, be careful about the sign. One was minus 2, other was plus 3. Okay? Yeah. Now, related to this concept is the concept of area of a parallelogram. So let me take this concept, area of a parallelogram. Because parallelogram involves two pairs of parallel lines. So this concept is going to be very helpful in that regard also. So let us say I have a parallelogram with me, okay, whose side equations are given to us. Okay, let's say ABCD is a parallelogram. Okay, whose side equations are given to us. Let's say I give you this side as a1x b1y plus c1 equal to 0. This is a1x plus b1y plus d1 equal to 0. Okay, this is, let's say, a2x plus b2y plus c2 equal to 0. And this is, let's say, a2x plus b2y plus d2 equal to 0. Okay, now I have to find out the area of this parallelogram. Let's say if I give you an opportunity to find the area of this parallelogram, how will you find it out? What would be your approach? Anybody who would like to share his roadmap or her roadmap with me? What would your approach be? So what is the area of a parallelogram? Base into height, right? Isn't it? So area of the parallelogram is base into height. So let's say this is height and this is your base, right? So what all will you do to find base and height? You will say, sir, I need coordinates of A. So for A, I need to solve AD equation and AB equation simultaneously. Correct? Then you need to get D and C points. For that, you need to solve AD and CD equation simultaneously and BC and CD equation simultaneously. Then you will use distance formula to get the CD length. And then you will do base into height. And one more thing, you will also do the distance of A from this line. Correct? My God, this is going to take a lot of time in your competitive exams. So what we have done is we have come up with a formula for this as well. Okay. And the formula is, note down, area of the parallelogram is given by C1 minus D1 mod C2 minus D2 mod by determinant, or you can say mod of the determinant A1, B1, A2, B2. I hope everybody knows determinant, right? You have done it in cross product of vectors, determinant. Okay, anyways, I'll write it down without determinant also. It doesn't take much of a time for me. So it is mod C1 minus D1 mod C2 minus D2 by mod of A1 B2 minus A2 B1. Okay, this formula can get you the result in fraction of a second. Not metaphorically, not literally. Okay, Now, $1,000,000 question is, sir, where do you get this formula from? What is the derivation of this formula? Okay, that is what we are going to do in the next, couple of minutes that is left for the class. Okay, let's derive it. Let's derive it. Why do you take C1, C2, D1, D2 the way you did? See, that is up to me, right? I can take C1, D1, C2, D2. But what is important here, Hariharan, is I have taken A1, X1, B1, Y1 for both this parallel lines. So these two lines are parallel, remember. Okay. So I have taken my coefficients of X and Y to be the same in these two parallel lines. Okay. And I varied the constants. Okay. Okay. Let us derive this formula. So in order to derive this formula, I would do a small step. Let me call this as P1. Okay. Let me call the height as P1. Okay. And let's extend this forward. Let's drop a perpendicular. Okay. Let me remove this equation from here. It is coming in my way. Probably I'll transfer it up. Yeah. Let me drop a perpendicular from the point D onto BC extended. And let's call this as P2. Okay. Let's say this angle is theta. You would all agree with me that if this is P2 and this is theta, then CD length would be P2 by sine theta. Do you agree with me or not? CD length would be P2 by sine theta. Correct? Okay. That is nothing but your base. Okay. And your height is nothing but your P1. Correct? Height is your P1. Right? So area of the parallelogram would be base into height, which is nothing but P1, P2 by sine theta. Correct? Now, what is P1? P1 is the distance between these two parallel lines, AB and CD. Correct? So what is P1? You already have done this concept in the previous slide. So P1 will be mod C1 minus D1 by under root of A1 square plus B1 square. Okay, previous formula. What's your P2? Mod C2 minus D2 by under root of A2 square plus B2 square. Correct? P1, P2, no issues. All of you please check this again. Distance between AB and CD is your P1 and it will be given by mod C1 minus D1 by under root of A1 square plus B1 square. And distance between AD and BC, whether you extend it or not, the distance will always be the same. Okay, so that distance would be nothing but mod C2 minus D2 by under root of A2 square plus B2 square. Okay, no problem with this. Okay, now sine theta is going to give us a little bit of trouble, but I'm sure you will be able to understand that. So theta is basically the angle, you can say the acute angle between CD and BC, isn't it? So CD slope, what is the slope of CD? I'll write it down over here. What is slope of CD? Slope of CD will be minus A1 by B1. And slope of BC is going to be minus A2 by B2. Correct? And this theta is the acute angle between them. So can I use my angle between the two lines formula? Tan theta is mod of M1 minus M2. M1 minus M2, let me write it like this. M1 minus M2, right? By 1 plus M1 M2. 1 plus M1 M2 will be A1 A2 by B1 B2. Correct? Yes or no? Tan theta is this. Nobody doubts it. Okay. Now, if you simplify this, it will give you A2 B1, or you can write it like this. Within the mod, you can take the liberty to switch terms. A1 B2 minus A2 B1. Okay. So A1 B2 minus A2 B1 mod by mod A1 A2 plus B1 B2. Okay. This is your tan theta. So if tan theta is known, what is sine theta? You will say, sir, simple. Sine theta will be perpendicular by hypotenuse. So hypotenuse will be under root of square of this term and square of this term. Correct? So square of this term will be A1 B2 minus A2 B1 square. and A1 A2 plus B1 B2 square. Correct? Yes or no? Any doubt? Any concerns? Okay, everything is fine. Okay, now what I'm going to do is I'm going to just simplify this a bit. So it's mod A1 B2 minus A2 B1. Here, if I open this square, open this squares, I will get see A1 square B2 square, A2 square B1 square minus 2A1 A2 B1 B2. Okay, is it fine? Somebody's camera is on. Hello. A1 square. But one thing I saw that you were listening to me very, very carefully. Thank you for doing that. There was one of the batches, I think last year only, somebody from NPS CHK. He was lying on his bed. Aram se he was like putting his mobile on top. And he was listening to it as if he's watching some Kapil Sharma show there. Oh, it was Charan. Charan, good to see you. Okay. So now these two will get cancelled off. Okay. From these two, if you take A1 square common, okay. So I'll take A1 square common from these two, and from these two I'll take B1 square common. Yeah. So A1 square common, I'll get A2 square plus B2 square. And if I take B1 square common, again I'll get A2 square plus B2 square. Okay. Thankfully, I can make a factor out of it. So this will become mod of, by the way, under root doesn't require a mod. Okay, please do not put a mod over here. It will be stupid to do that, because under root quantities are already known to be positive, so you don't have to put a mod next to them. Okay. Wow. So this is finally sine of theta. But see, once you're done, you can make use of that formula. I understand in the beginning there would be a bit of churning happening. Okay. Now, finally, if you put it in the area of the parallelogram, it will be P1 P2 by sine theta. So P1 P2, P1 P2 by sine theta. Let us put in the expressions finally. So P1 is mod C1 minus D1 by under root of A1 square plus B1 square. P2 will be mod C2 minus D2 by under root of A2 square plus B2 square. And sine theta in the denominator, my dear, would leave you with A1 B2 minus A2 B1. And this denominator will go up. This guy will go up. Okay. So this guy will go up and become under root A1 square plus B1 square into under root of A2 square plus B2 square. So this will happily cancel out with this. This will happily cancel out with this. Okay. So after so much of effort, we have finally done with our expression, that is C1 minus D1 mod C2 minus D2 by mod A1 B2 minus A2 B1. Okay, just remember this or note this down somewhere. It'll save a lot of time for you. It'll save a lot of time for you. Okay, so one quick question before I end the class. Okay, just a quick question. Let's say there is a rhombus. There is a rhombus whose sides are given by this equation: x plus y plus 1 equal to 0, x plus y minus 1 equal to 0, x minus y plus 1 equal to 0, and x minus y minus 1 equal to 0. Please give me the area of this rhombus. Please give me the area of the rhombus. You have only 1 minute to do this, lesser than that, in fact. Done, 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 done. Okay, let me write it down. A1 is 1, B1 is 1, C1 is 1, D1 is minus 1. Okay. A2 is 1, B2 is minus 1, C2 is 1, and D2 is minus 1. Okay. Now use your formula. Mod C1 minus D1 is mod 2. Mod C2 minus D2 is again mod 2 by mod A1 B2. A1 B2 is minus 1 minus A2 B1. A2 B1 is again a 1. So you'll have 4 by mod of minus 2. Answer is 2 square units. Straight away, done. Okay. So fine. So we'll